you for having me back, even if it's just for an hour. It's good. It's nice to be back as a visitor. And yeah, this is the title of the presentation. But first, I'm just going to introduce you to EMR, to East Malling Research, the place that is actually hosting me at the moment. I'm just going to give you a bit of the history of the site and some brief developments in terms of techniques and technologies and what the center is like now. And then I'm going to move on to one of the main matters of discussion, so soft fruit production. And then the other bit of the discussion, which is the main part, which is the precision irrigation system, which is one of the main projects I am working in at the moment. And then I'm going to give you a bit of info on further research that the center is working on. And then I'm going to introduce you to the wet center, which is a major part of the research at East Malling. So without further ado, let's do this. I'll try to be as quick as possible because I understand I went through the presentation a couple of times already. I didn't have a lot of time to prepare it because I've been busy with other projects during the last few weeks. So I'll try to go through like the wind. So a bit of history. First, the East Malling Research Center was officially born in 1913, so it's more than 100 years old. And at first it was a public research institute because it was founded by Kent County Council, which gave the center the first 9 hectares to start field trialing. And that man on the right is the first director of the center, which stayed for just 1 year. These are just some of the techniques and research facilities that were used back in the days. This on the upper left is root storage lab, which was established in 1960, and I think right now is in use no more. On the right, that's how they used to measure shoot growth in the 20s and 30s. The excavated tree is for root growth work back in the days. And that lab is one of the first labs for the entomology and pathology departments. And so what is NIAB EMR now? It's an internationally recognized center for plant science and agronomy that hosts 3 departments: crop science and production systems, which is the department that I am working for, pest and pathogen, and genetics. And it acts as a bridge between the needs of the industry, the agricultural and horticultural industry, and research through commercial applications, therefore making business more profitable. That's the main motto of the center. So the staff member body is huge. Turnover is huge. We have unique research facilities such as controlled atmosphere storages, concept orchards, and hectares of growing trials for novel crops and varieties. And of course, it is part of a global research network and partners. We have partners across the UK and across the world. And of course, it's more than 100 years old. So it has a worldwide reputation and established reputation. And we apply our research to perennial fruits, top fruits, apples, pears, cherries and plums, soft fruits, mostly raspberries, strawberries, and blackcurrants or blackberries. I still don't know the difference, but I think it's blackberries. For me, it's blackberries. And then on non-food products and other horticultural crops such as mushrooms and vegetables. So what's NIOB EMR is all about? It is about improving best practices, crop yields, product quality, and shelf life. From Kent to Kenya, it refers to the fact that it doesn't do research only in Kent, only in the UK, but it goes beyond the national borders. Currently, there's my head of department is following a project in Kenya on developing new integrated soil management strategies to prevent wilt syndrome in runner and fine beans in Kenya. And as for commercial rollout, I mentioned the wet center, which I'm going to talk about at the end of the presentation. The wet center is a demonstration center that we have on site in which we trial techniques and technologies. We develop them on site and then we make them extendable to industry. So there's one part of the talk in which we are delving into the UK soft fruit production, which is a huge sector, there's been a huge rise in tonnage and revenues in the last 10 to 15 years because of the expansion of protected areas. Right now, less than 10% of soft fruit production in the UK is soil-based now. And not just because of that, because of better agronomy techniques and new varieties development. And of course, the imports are still important. The worth is actually quite big, so the room for research is actually very big. You know, room for improvement in that sense is actually huge, and production worth is actually very high. So it's a main sector, and it's about, it's a high value horticultural sector because that's, we are talking about thousands of pounds per ton of product in the end. For the sector, the main challenges come from mostly water-related issues. So yes, water is cheap and really available, but technically it's not an infinite supply. It's not an infinite resource. So there's increasing pressure on the supplies and of course the related environmental impacts, and the changes in water abstractions are going to change come 2019. There's going to be a reform which is going to limit the volumes of water that growers can abstract. So drivers for change refers mostly to improving product quality and uniformity, avoid pests and disease, to make better use of water, energy, and fertilizers, and to increasing yields and crop profitability and the overall environmental sustainability. So the main problem is, concerning irrigation, the main problems is matching supply with demand. The graph actually shows you the volumes of water that are ideally applied throughout the cropping season. You see, it can, they can vary up to 13-fold, 15-fold. And temporary deficits can have huge effects on yields and fruit quality. And of course, there's also the grower fear factor, which is, growers' apprehension that the irrigation is going to be handed to other tools other than themselves. But again, there are irrigation scheduling tools and services that help growers to improve on-farm decision-making in that sense. So there are many different tools going from soil moisture sensors to using environmental parameters such as soil radiation to, of course, aid growers in keeping up with, water supply and irrigation requirements for the crops. This irrigation scheduling tools and techniques make use of the soil metric potential, which is a parameter that refers to how much water is actually available to plants instead of soil water content. And there are, it's a parameter that is directly related to plant water stress. And there are also other ways to measure and reveal plant water stress, such as physiological measurements of leaf growth and fruit expansion, and of course, yield and quality assessment. And now we get to the main part of the discussion, which is a project that I've been working a lot on, which is the precision irrigation technologies. And yes, you can see to the left, this is a very, very basic scheme of how precision irrigation package works. So there's this data logger, which is connected to the soil moisture sensors, which are spread across the site, the commercial site. They measure soil moisture content and electrical conductivity. They give these data back to the logger, which is remotely controlled and is so you can actually see the data on your computer. And to the right side, you can actually see the difference between grow regime irrigation, which is the blue line, and the precision irrigation scheme. So you can see that the precision irrigation system gives consistency of water supply to the plants, whereas the grower, in all his experience, could come across, temporal deficits and have yield losses in the end, and of course that could have repercussions on fruit quality. So you can see that big dip, in April actually cost that grower 7% loss in yield at the end of the cropping season. So yeah, this is more info on the precision irrigation package. So again, as I said, it gives, it feeds water in a consistent way, delivers target runoffs, volumes, and so it matches crop demand with supply, with water supply. Avoids water deficits because the system actually is called, irrigation is called from remote if, the plants actually require water. The system sends an alarm to the irrigation system so the irrigation can start. So basically, it's the plants that ask for water by themselves. And so in that sense, it helps the grower optimize crop yields and fruit quality, and canopy size and light interception, and of course it complies with the new legislation and whatever comes after. And it can be done on a commercial scale. So this is, yeah, I mean, you can focus on the words, but also look at the pictures. This is soil moisture sensor inside the growth bag, so that measure the soil moisture content and the electrical conductivity. That is the main system. So this is the main data logger that collects data and send it remotely to the computer. This is the modem that is connected to the logger, which make it, work, because it's basically a battery. And of course, the whole system is connected to the solar panel, which feeds into the modem. So it's partly battery powered and solar powered. And this is actually a screenshot of what the data from the logger actually looks like when you look it on the computer. This is basically the irrigation control, which opens and closes whenever the plants actually need it. And these are all the moisture sensors in action. So this is, percentage of the moisture that they register. And this is the average moisture that they give altogether. So it can be averaged. And of course, all of this is aided by the NIAB EMR staff, which goes weekly on site to actually, measure soil moisture contents and electrical conductivity all over the site, the farm site, to keep up with the logger to see if, data actually coincides or not. And of course, you can set the irrigation set points, and every variety and every crop has a different one. The irrigation set points means that you can actually set the percentage of moisture at which the irrigation system will actually start functioning. And what else? So yeah, the signal is sent to the rig, so to the irrigation system once the set point is reached, so the plant actually asks for water. So they send a signal, the alarm, to the system, and the signal comes back and start the irrigation event. And everything is accounted for. So it's actually a huge aid to growers to try and match, crop demand with water supply. And of course, it has its benefits to growers because it gives, since it takes care of temporary water deficits, it gives a consistent yield, and of course it helps fruit quality. It's an improved time management for the staff. It's an aid in decision making, and it saves water and fertilizers. It saves up to 36% of water supplies, which is a huge cut in water costs. And to retailers, of course, it gives a constant and improved supply of fresh fruit and of high quality, and as an assured shelf life. So there's a reduced wastage in store, and it's an innovative production method in order to make the system more intensive, but at the same time more sustainable, and to consumers, of course, gives high quality fruit, and it's basically locally sourced. In that sense, NIABMR as a research center is working in this context, is working towards improving yield forecasting on both short, medium term, and of course longer term, to help in identifying nutrient requirements for varieties and crops in order to develop more, let's say, tailored fertigation regimes, and improve crop resilience, and of course integrate these new technologies into grower decision making, and of course farm management, crop management. And on this note, all this is actually showed in the WET Center, which stands for Water Efficient Technology Center, which is a center that we have on site. These are some of the partners that we work with. So the WET Center itself has the main objective of demonstrating that these technologies actually help growers in their farm management, crop management, and decision making. So growers and industry stakeholders can actually come to the center and see for themselves the the workings of these new technologies. So the WET Center itself is there to develop and make these irrigation technologies marketable, extendable to industry. So it's a demonstration center of demonstrate how the application of these cutting-edge technologies can actually enable growers to improve the water use efficiency, which is a big matter, their crop yields, their fruit quality, and of course, since it's there to make business more profitable, to increase their financial returns. And of course, is there also to provide growers with workshops, training, and one-to-one technical support to enable them to actually adopt these new technologies in a successful way. And this is it. Thank you for listening. I don't know if you actually liked it.